we get started today, before we move to today's feature presentation, we are going to talk a little bit about the ISAC Tech Conference that will be held in Atlanta, Georgia next year, April 14th through the 17th. We'll open with a reception on Monday the 14th, and then 3 days of technical sessions, breakouts, keynotes, workshops, etc. Very excited about this conference. Some wonderful sponsorship from SAP, who will also be providing an awful lot of content related to new versions of new products that will be coming out next year. We are still have our call for papers open through the end of next Monday. That's December 16th. With the additional SAP sponsorship and their need to get their content submitted, we did extend that for a week. So you have the opportunity, if you're wanting or considering to submit a session, to still do so. Session abstracts and descriptions need to be submitted by Monday. The actual sessions are not required until March of 2014, though, so you have plenty of time to actually develop your session. If you're concerned about getting the session written in the next week, that's not necessarily the case. You do have several weeks in order to actually put the session itself together. But the submissions do need to be received by close of business on Monday. Also, our early bird registration is open for the conference. The Ultra Early Bird Special is still going. What that is the first 250 people who register for the price of the conference fee, you're actually going to get 3 nights of hotel. That's Monday, Tuesday, and Wednesday nights included in the conference fee. And then once those 250 slots sell out, then we will move to our regular early bird, which won't be quite as special, but will still be a good price for you guys. ISAC Tech Gold members do receive a significant discount on the conference, so if you're a Gold member, please do look into that. And if you're not a Gold member, please consider becoming a Gold member in order to secure the best price for the conference. Okay, so let's move on, please. And we are ready now to move to Chris. Chris has been traveling today and is in the Dallas office, where I understand it's a little bit colder than it is usually down there, with a snowstorm that's hit most of the country recently. So Chris should be ready to go, and when you're ready, there we go. All yours, Chris.
All right, thanks, Mike. Hopefully, Mike, are you able to see my screen?
Yes, I can. Just needs to go to slideshow.
Excellent, excellent. All right. So again, welcome everyone. As Mike said, my name is Chris Brown. I'm with our Enterprise Solutions Group, formerly the Evangelism Group from Sybase, and it is very cold in North Texas, and they're forecasting another ice storm, so hopefully, at least north of here, so hopefully that'll avoid here in the next couple of days. But I want to spend about the next 30 to 40 minutes or so just discussing our Replication Server product, which I'm sure many of you are familiar with, and get into some futures and roadmaps of where we are taking the product and some planned innovations that we currently have, a few of which honestly I'm very excited about, because I think they're going to bring significant value not only to existing customers but also to new customers who may be looking at the product or who have not ever used it before, and provide some real value there, especially for Business Suite and or customers who are looking to replicate into the HANA product from SAP. So we'll start with just a quick, that top half there with a product overview. I'm going to really breeze through that, because really I think the meat of what everybody's here for is trying to understand, get rid of that, is trying to understand the where we're going with the product, not only where we are today and where we have been, but what we're planning to do and move into the future as we move forward over the next, say, year or 2 year and a half. So I think everybody's fairly familiar with Replication Server that's on the line. It's been around for quite a long time, and its real mission in life is just to simply move the data transactionally from one point to another. Initially, mostly when the product was developed back in the early 90s, it was more of a Sybase to Sybase solution, but quickly we moved it into more of a heterogeneous environment. So we look at it as taking any transaction that occurs in any database, well, I say any database, pretty much any major database, so being Oracle, IBM, DB2, both LAN and on the mainframe, Oracle and our own ASE, and eventually HANA, and replicating that out to any other target data source in your environment. And again, we do that transactionally, so as the SQL statement or command exists at the primary, It is reinvoked at the replicate identically and in the target database's native SQL dialect. So this is a product that we've had, for quite a while. We've been in this business and have led that business for many years. And over the years, we have invested significantly here to add different functionality to the product itself. So, we added initially a warm standby capability so that we were able to have a true warm standby that was up and running, and you could easily switch back and forth and manage that from Replication Server. We've added capabilities to have multiple standbys now, so that really lifted the limitation that we had for many years of just one primary, one warm standby. Now you can have any number of warm standbys for that one primary database that you have in your environment. Because of the way that we replicate data, we are very lightweight on the network. So a lot of the other products out there either work with triggers in the primary database to move data across, or they move a significant amount of data. And we work quite differently than that. We are agent-based. We read the primary database transaction log and move only the data that is marked for replication at the table level. So it's quite simple in the way that it's implemented. Again, we just mark the tables that we want at the primary side to be replicated, and those are read by our agent within the primary database's transaction log and replicated across to a target environment based on a publish and subscribe model. We also fully support bidirectional replication, and we have several customers that do use that. So this allows for scenarios such as distributed applications, so that we don't have to go across the WAN or go across a very long distance and incur that performance penalty of doing so to access data at a very remote database. We can have that replicated locally and have local access to that data and bidirectionally replicate changes across and have everybody view the same data. Sybase has actually used this for many years prior to the acquisition by SAP to do things like global support and follow the sun type of support. So if you called in and opened a case and it was opened in, say, California, as the sun would move around the world, that data would also move to the appropriate data center, and it'd always be caught up, and we'd move that data back and forth. We also have several interesting and complex architectures that customers have out there where we do bidirectionally replicate data from one source to the other and keep everything in sync all at the same time. And we've been doing that for quite a long time now. It also allows you to do offload reporting off to a reporting server. So it has somewhat of an ETL feature that you are able to load a data warehouse, including our own IQ product, and very soon SAP's HANA. And it allows for just real-time data sharing and synchronization. Replication Server was always designed to be a real-time data movement product and not a batch-oriented product. It's more of a real-time product. So we allow you to do that type of data movement real-time again, and it allows you to make real-time decisions based on what's going on currently in your environment versus doing it on a time-based basis. And for certain applications, as you can probably understand, that would be extremely attractive in, if you think of market-based activity or trending any kind of data flow over time, like in a telecommunication system where we're looking at load on a particular network or on a particular cell tower or something like that at a particular time. It's really nice to know real time what's going on in that system so that we can distribute and maybe make business decisions based on what's going on real time and not affect our online system at that current time. It's architected.
Hey, Chris.
Yes. Yes, Mike. I'm not sure if I lost Mike, but Mike, if you have a question, just go ahead and hit back.
Yeah,
so,
sorry. It looks like the right side of your screen is being shaded by the GoToMeeting panel.
Okay. Let me. That goes to the left. My options are undock and quit. Let's try. Is that better? I moved it down to the bottom, so hopefully that's better.
Yeah, that looks better.
Okay, excellent.
Thank you.
Thanks, Mike. So we have architected replication server, as we say here, for enterprise IT needs. And you know, I'm a technology guy who happens to be in sales. So a lot of the sales and marketing related material that comes out to me is a lot of fluff. But what we like to talk about here is that we are really architecting this for high performance and high throughput. Many of the sites that I've worked on, personally worked on, we were able to move data with very minimal, if not sub-second latency from point A to point B, and that could be halfway around the world. Obviously, if you think about the latency that's built into any network architecture, that's something you're going to have no matter what. But we are able to do that data movement extremely efficiently and handle a large amount of data moving at one time. So I've worked on systems where we've moved and been able to replicate, 5,000 commands a second and greater with zero or near zero latency. So it is a very high-performing asynchronous-based data movement product. Now, because it is asynchronous, again, we have built-in latency because of that. We do not do things synchronously, but we think that from an architecture perspective, that is probably the better way to go, because anytime you introduce synchronous-based things into your environment, that has ramifications, not only at the replication level, but also on the performance level. So we feel that we would want to minimize any type of impact at the primary database and then move that data on down. So we do that asynchronously to again, minimize impact on the primary database. So our sources, as we said before, are any of the major databases that are listed on the left, and we can go to pretty much anything on the right, including message buses, or anything that we can hit with an ODBC driver. So quite a bit of flexibility there. The architecture can be somewhat simplified because we allow routing in between individual replication servers themselves so that it changes the architecture and simplifies it significantly. So you don't get into point-to-point type of architectures. I always like to liken this a little bit to some of the airline routes that are out there. You have some that do point-to-point type of things, so you have to go through a lot of hops to get from point A to point B, and then you go into more the hub-and-spoke type of architectures to where it pretty much goes centrally to one place and then gets distributed out, and it tends to be more efficient from a business perspective to do that, and we work along that model. So again, it's a real-time movement product, and it is built for performance and high throughput. And if this will click forward, there we go. So from an architecture perspective, this is true no matter what the primary and what the replicate would be. So from an inbound side, so this is moving data out of the primary. We have our source database there listed on the left. And we have our own replication agent that reads the primary source database's transaction log. Now that rep agent there is either internal or external depending on the database. It's internal with an ASE, so it's part of the data server binary that Sybase SAP ASE is. Or it's external in the case of Oracle or DB2. And we read that transaction log and we copy or transfer the rows that have changed in a SQL dialect perspective from that source database out to an inbound replication server. And as you see there in the middle, we're moving that into that centralized replication server, and we store it in an inbound queue. So we do have the concept of a little bit of a store and forward type of architecture, but we do that for a couple of different reasons. One is for recoverability. And the other is because if we, for any reason, have a target database down or we get behind for any particular reason, we want to make sure that that is stored in an intermediary queue, again, minimizing the impact on the primary database and not ever getting into the situation where you fill up the primary database's transaction log. Again, we want to have a minimal activity or minimal impact on that primary database. So we want to get it out of there as fast as we can. So we will store it in an inbound, this says stable device. You'll also hear it called a stable queue. Now once we do that, we will look somewhere, we will look inside what we call an RSSD, which is the Replication Server System Database, and we will determine where downstream we need to ship that data. And then once we do that, we will move it on downstream to our target database. Now in that RSSD there at the middle top, in the primary slide you saw something called a replication definition, and this one you see subscriptions and routes. So if you think of a replication definition, that is what we're publishing. Again, we're a publish and subscribe model. So whatever's published at the primary database for replication, we will also take a subscription, also stored in that RSSD. We will match that up and determine where downstream we need to send it. So that can either be the target database, or it can be another replication server somewhere else in your environment that may sit locally to the target database. Again, because we're moving minimal data that way, it can be more efficient to do that. And you can have multiple routes in between those replication servers to move that data. And then if you see it on the bottom there, again, we're still using our stable device because we will move the data from that inbound queue, that pink queue on the left, which we had on our primary slide, to the replicate database's outbound queue, and again store that data until it's applied at the replicate data, and then we move on. So again, the most important takeaway here is that it is a publish and subscribe model, and we publish at the left side what we want to replicate, and we subscribe to it on the right side. And that does not necessarily have to be one-to-one. So for example, I can have one replication definition or publication at the primary and have multiple subscriptions to it. I can subscribe to that data based on where clauses or any SQL that I could possibly write to apply it at the replicate based on the business need. I can also change that data as it goes across. So for example, on the primary side, I could have a table modification occur, and on the right side of the target, I could have a store procedure be executed. Or I could obfuscate some of that data as it moves across because I don't necessarily need it, or I need to make sure that for privacy reasons it never makes it out or it's changed. I can have that source database be Sybase ASE, for example, and on the right side I can have that be Oracle, which are obviously two SQL dialects, and the type of SQL that's going to be executed at that replicate can be significantly different than what's at the primary. So I like to tell customers once I get that data out of the primary database, I can really do whatever I want with it as long as SQL allows it. So it's quite flexible, and you can change it in any way you want to, depending on your business need. Again, it's a comprehensive real-time data movement solution. This slide just goes over a lot of what we've already talked about. One of the things I do want to pull out of this slide and mention are the two bottom points. We do have full security support. This was something that was added in some earlier versions of Replication Server, so we can do SSL-based replication, so it's secure from source to target if you need that type of encryption. We do have Kerberos-based support, so if you have a Kerberos-based security system in your environment, we can integrate with that for permissions and to make sure that we're moving data securely from point A to point B. And we do provide some auditing capabilities as well. So if you need to audit what's being moved or what's happened in your environment, we are able to do that. And we do support full internationalization as well. So for Unicode and non-Unicode based languages out there, we fully support that and have for a number of releases now. We also talk, and I have talked a lot about the desire to be non-intrusive or as little intrusion as possible at the source, and we do try to do that at the target as well. But on the primary side, again, we read the primary database's transaction log, and we pull that out and put it into our Replication Server's inbound queue. And then once we go to the target database, we're just another user that logs in. If you do a lot with Replication Server, you'll hear us talk about, or you'll be familiar with the maintenance user. That is just a thread from Replication Server that logs into the target and applies the SQL-based transactions. And that is just another user that logs in, and we are able to parallelize that as well for not only reductions in latency, but also more efficient data application at the replicate. And we do that for, again, no matter what the primary or what the target may be, it all works the same way. Now, this is something that we added in the 12.x version of Replication Server, and then have improved it in the 15.x version of Replication Server, and even with 16 Power Designer. So this is something I never really used until recently, and I've started using it a lot more, especially as I do heterogeneous-based replication, and I'm really a big proponent of it. So Replication Server does have, or I should say, Power Designer does have hooks into Replication Server so that you can fully model your replication environment. And it allows you to do very complex things without having to write a lot of SQL. So in this particular example, I can model my replication environment from my primary to my source, and this could be heterogeneous, by the way. Excuse me. This could be heterogeneous, by the way, so that you can take a primary database and mark the tables that you want for a replication, and then how you want those applied to the replicate, have any kind of scripts generated to do that within Replication Server or the primary or the target, and have that all deployed, and then manage it inside of Power Designer itself, and take advantage of some of Power Designer's capabilities, such as versioning and modeling and a central repository for all of that, and ease of use of rebuilding an environment should you need to, and all the things that really Power Designer bring into that. And as you move into some of the more complex environments, or if you start looking at things like change data capture to load a, for example, a data warehouse, or if you're going to look at SAP's data services product, which uses change data capture, Replication Servers and Power Designer are key components of that, and they can really make things a lot easier, especially in complex environments. So if you're getting into RepServer, or even if you're a longtime RepServer user, this is something that I have started to wholeheartedly recommend, and it's something that I do use myself. And those of you who know me know I'm a command line guy, and I think that this is a great product to be able to better manage from a design and architecture perspective your replication environment. So we've talked about the usage scenarios. I'm not going to cover these too heavily. Just data distribution and migration in your environment, decision support, and disaster recovery. Those are really the three sweet spots the Replication Server has, and these are things we've been doing for many, many, many years. And we like to think that we are the market leader in that area, and our customers are very happy with the product who are using it in this particular area. From a disaster recovery perspective, it kind of goes without saying that the whole idea here is just to keep a data center, no matter where it is in your environment, whether it's local or whether it's somewhere halfway around the world, in sync with your primary, so that you are easily able to fail over from the primary to replicate with very minimal data loss. And I want to keep that kind of as a little asterisk at the end of that because we've got some things coming up in future replication releases that will lead to more of a zero data loss solution going forward. But right now, the way the product works is we have our primary data center. It goes offline, and we've kept a warm data center somewhere else in our environment. We can very quickly fail over to that data center that's already online and point our users to it. And the nice thing about this is that in some scenarios, when you do a failover, it's an all or nothing thing. So if you're going to fail a data center over, or you're going to fail an application over, or you're going to fail a SAN over, sometimes it's an all or nothing thing, and everything attached to that has to go as well. Well, with Replication Server, it really doesn't work that way. Only the application or the database or the system that went down has to be failed over. So it really makes failover times a lot quicker and a lot simpler in your environment. And as this says here, we don't have geographic restrictions. It really doesn't. We have customers that are doing this, again, halfway around the world on different continents and doing it, and have been doing it for many, many, many years quite effectively. From a decision support perspective, again, loading a data from a primary database or an online database into a more of a warehouse or into SAP HANA coming forth, and even into our own IQ product. And one of the things that has recently been released and is integrated with the Power Designer product that I mentioned earlier is the idea of change data capture. So part of decision support, and one of the big usage scenarios for decision support is a history or maintaining some type of audit trail of what's changed in an environment. And in order to do that before, it could be quite tricky because you really have to keep a copy of, if an update occurs, you want to keep the before and after value. If a delete occurs, you want to know who deleted it and at what time it was deleted and maybe what system it came out of. And a lot of that had to be coded in the past. Well, Power Designer can really automate that for you. And it has a whole change data capture plugin to it that will really facilitate the ease of deployment of that. And you can really have a change data capture scenario into a DSS environment using Replication Server built in just a matter of hours. It's actually very quick, and I've personally been involved in some of that. which is one of the reasons why I'm such a big fan of Power Designer now, because I've tried to hand code that, and it was quite a laborious task. So being able to do that now with Power Designer is a very good thing, and we fully support that and can deploy that quickly. Distribution and consolidation, again, based on where clauses in the publish and subscribe model, fully supported and have been doing that for a very long time. So as this graphic shows you, if my online system's in San Francisco, I can, based on replication definitions and subscriptions, I can definitely apply data at the appropriate target data center based on that particular system's needs. So as this says on the right here, the sales probably doesn't care about everything that goes on in the order processing system. They probably only care about new customers or new orders that have gone in. They don't really care about things that the finance department would care about and who would not care about who the manufacturers care about. So you can definitely fine-grain that data distribution down based on a where clause, again, based on one publication. My clicker's not working there. There we go. So let's get in a little bit to where we're moving in the future. And there's a lot on this slide, so I'm going to spend a little bit here talking about where we are today and where we're going. And there's a couple things I really want to hammer on that I think are very exciting from a product perspective. So we'll start here on the left. Where we're at today, the current version is actually 15.7.1 SP113. It's a current in-market release. And it fully supports everything that is in the ASC 15.7 SP110 code line. This says 100, but it's actually 110. So we're at feature parity with everything ASC has. And we are replicating into HANA now. That is actually something that was in ramp up for quite a long time. But if you happen to go to Tech Ed, or you're going to the ISAG Tech Wave here coming up in April, we'll definitely be able to support that and show that happening real time. We're fully supporting the Business Suite on ASE and replicating out of Business Suite into a warm standby scenario for SAP's Business Suite as well. We also have what we're calling a real-time materialization. So part of the problem of any kind of replication in the past has been set up on that. So if you need to materialize your data from your primary to your replicate, there were always quite a bit of steps involved in doing that. So you had to either take a backup of the primary and the replicate and then figure out how you're going to deal with changes while that happened, whether you took an outage or you queued them up, or whatever made sense in your environment. There was always a way, there was always a little bit of difficulty, especially in larger systems, about how to be able to do that and do it with minimal downtime. In the current product, we have what we call real-time materialization. So we're able to materialize that data much, much better than we ever have in the past. And generally that materialization was quite slow. Now we're able to do it quite quickly and really get these systems up and synchronized much, much quicker than we ever have in the past. We also have data assurance, which we'll talk a little bit about. Initially that was an ASC to ASC only option. But now it really supports heterogeneous databases. So if you think about that, part of any replication environment is as you move that data across, you want to make sure that what you're replicating is actually what you think you're replicating, and that's extremely important in in warm standby systems, as well as decision support systems. You want to make sure that the data's made it across, and it is data that you can rest assured that if you had to fail over, or you had to run your business queries or any type of decision-based queries, that you are getting the data that you want. And this data assurance option, which is part of Replication Server, really allows you to do that. We always had a product called RS Subcompare that would let you do some of that, but it had a lot of shortcomings to it. Data assurance is much more flexible and supports heterogeneous databases much better. Plus it has reporting facilities and it performs better, and it is more of an agent-based type of thing, so it's not sucking all the data across the network. Good product if you're looking at something in that area to really make sure that what you publish and what you're subscribing to is in sync. So let's move a little bit to the middle and to the right. So where we're going, you'll see a lot of commonalities here. There's really going to be three. We're always looking to improve performance and support in-market releases of not only ASE, but also the heterogeneous databases that we support. So the big one right now for us is HANA and being able to replicate to that. We're also planning to support replication out of HANA in the near future, and we're currently working on that now. So replication, again, HANA to HANA or HANA to any other target database will be supported soon. We also will take data assurance and allow that to not only support the current databases that it does, but also integrate HANA in there. That will be forthcoming very, very soon as well. But the one that I really want to talk a lot about, and I'm probably the most excited about, is this one called ZDL, support for HA and DR using synchronous replication. Now, there's a lot there because I've talked a lot about how Replication Server is an asynchronous-based product, and then I go and have a slide that talks about synchronous-based replication there, so it's kind of a bit confusing. So let's talk a little bit about what that is. So one of the things that has always been, I guess, kind of one of the design issues with Replication Server is because it's asynchronous, there's always been a chance that if the primary database were to crash for any reason, there was a chance that if a transaction had not been read by the replication agent, it might not have been copied out of the primary database. So there was a chance that when you did fail over, or if you did try to do any kind of query at the target, that data may not have made it across. And it's something that you kind of had to learn to somehow deal with in the environment, whether it's from a business perspective or how would I materialize that data. And if the primary comes back up, we can get the data across, but what do I do in the meantime? So that was one of the things that has always been a design and architecture issue with Replication Server, and it's something that our competition has always used against us in the past. Coming forward in the very near future, we will have something called zero data loss replication. So it's really not synchronous replication as this implies it to be. We are not doing a synchronous data movement from the primary database to the target. So there's no concept of I've inserted the record at the primary or the row at the primary, and I'm waiting till it gets applied at the replicate before I return control back to the primary database and say the transaction is committed. We're not working that way. Replication Server, for the most part, will still continue to be asynchronous as it always has. However, what will be synchronous is the copy of the transaction from the primary database's transaction log into the inbound queue of the Replication Server. So when your transaction commits at the primary, we will copy that transaction into the inbound queue of Replication Server so that you will never run into a situation where there is a transaction, quote unquote, stuck in the primary transaction log if it were to go down. So for any type of disaster recovery or HA type of scenario, it really gets away from that issue. So we will be able to effectively ensure that a transaction will move from the primary to the replicate. So if you fail over, everything will be there, and it will be completely in sync. This is something that is currently in a ramp-up phase right now and will be released next year. And it's something that I'm actually pretty excited about because, again, it's been one of the architectural issues that Replication Server's kind of always had from day one, and it will finally solve that problem. We will be adding monitoring support and administration report for HANA replication as well. And we will improve our integration with SAP Data Services as well. So if any of you have looked at that product that SAP offers, we will be feeding data services from a database perspective using Replication Server. So there'll be more full integration of Replication Server into the data services product from SAP as well. And then moving out into the far future, this says Unified Real-Time Data Platform Replication. So SAP has a concept of a real-time data platform that really centers around HANA, but really these Sybase products as they exist today, whether they be ASE, Replication Server, ASA, or any of the, even IQ, any of the products that Sybase brought to the table via the acquisition are going to be a very critical part of the real-time data platform, of which HANA is the center. So you'll see more integration of the product lines into that architecture. So we will extend, for example, our HA and DR and our synchronous replication to all of our ASE customers. Initially, it was targeted more for the Business Suite customers, but it will go and will be available for all of our ASE customers. So don't worry there. Everybody will be able to utilize that. We will continue to improve HANA replication and improve throughput of that because it's an in-memory database, and if we're going to be replicating out of it, the transactional volumes that could be generated by that type of data activity could be quite significant. So we will continue to improve data distribution and performance specifically for HANA and in-memory based databases. We will also continue to improve our integration with data services and replication server. So right now, we only support really a couple of different DBMSs, Oracle, and then we have a staging database that's ASE now. We will improve that so that we really are a lot more database agnostic as to what the source and any kind of staging database can be, so that we will not be tied to specific DBMSs, and improve the data services product from SAP. We'll continue to improve any kind of administration and monitoring support for HANA. And we'll start looking at database replication to the cloud. So this is always an interesting one because I think when you talk to people and ask them what they think the cloud is, you tend to get a lot of different answers from people as to what that really means and what that can really offer a customer. And then you get into conversations about public clouds and private clouds and data security and where does data reside, and do I really care where the data resides as I start to retrieve it, and how do I distribute that data appropriately and make sure that it's in sync everywhere. So Sybase, even prior to the acquisition, had started looking at how we would integrate well not only the ASE product but also the replication server product to really support more cloud-based topologies. And it's something that we are actively working inside of engineering to try to better support and understand how we can help our customers better integrate into the cloud-based architectures, not only public but also private, and deal with the security concerns that go along with that. So that was really our product roadmap, and at that, I would like to hand it back over to Mark. If Mike's still on the call.
Thank you, Chris. Appreciate that. Very good presentation, very concise, and hopefully that was of use to everybody who was on the call today. We have had a number of questions come in on the console. We will be doing a Q&A session at the end where we will be asking those questions. So hang tight until the end of our second part of the presentation today, and we'll come to the Q&A at that time. So at this point, it is my pleasure to hand over to Bill Baker from Bradmark Technologies. Bill will be talking about the surveillance tool for which Bradmark produces, which monitors Replication Server as well as ASE and IQ. And Bill will be going through several of these items within surveillance this afternoon with us today. So, Bill, I've handed the presentation to you. Whenever you're ready, you can begin.
Okay, Mike, can you see my screen okay?
Yes, thank you.
Okay, thank you. Great presentation, Chris. Pointed out a lot of things that I'm sure everybody's interested in, and some of those things I'll touch here in as I go through my presentation. So for this part of today's webinar, we're going to focus on some general SAP RepServer monitoring techniques. And talk about what to look for when monitoring the different components of RepServer that Chris pointed out to us. And following that, we're going to show you how Bradmark's solution, Surveillance DB for Replication Server, automates these techniques and provides for you real-time monitoring and unattended event management to ensure that your replication environment is up and running efficiently. So when I talk to DBAs out there, there's different monitoring techniques that people use for a replication server, and that's also true of the other database flavors. But A lot of people are writing their own scripts. They're using the statistics monitor counters, stored procedures that are provided by SAP, the admin Hue command, Sybase Central, particularly the RSM event monitoring. And then there's third-party tools like Surveillance DB for Replication Server, which is the solution that we'll be talking about today. So real-time monitoring of the replication environment, as we know, is very critical. And time is actually one of the most important factors involving replication. And by that I mean time to detect an issue, time to fix an issue, as I'm sure we're all aware of. For instance, if any of the connections get suspended for an extended period, then stable devices may fill up, replication agents may become suspended, transaction logs can fill up, causing suspended or aborted transactions. So the objective of general monitoring is to make sure that all the basic components of the replication system are up and running, and secondly, to avoid any preventable system failures. So general monitoring is divided into the four main characters that you see listed here on this slide. And we'll step through each of these on the following slides. And as a note, these are the same requirements that Surveillance for RepServer solution was built around. And its value to the DBAs is reducing the time and effort by automating this process, automating the collection, the display of critical availability, and performance metrics. So there's two basic types of servers involved in replication. They are database servers and replication servers. So looking at the database servers, there's an additional three types of database servers that must be monitored, and that's the primary database, the replicate database, and the RSSD. So one of the most important databases of any replication environment is the primary database. So here's where the source data gets updated. It gets marked for replication to the replicate database. So the status up or down of the primary database and the connection routes to and from the primary databases, as well as any changes to the object structures or permissions that control access to the data in the primary database, must also be monitored. So in a standby or a disaster recovery environment, the replicate database server may be just as critical as the primary. So usually one replication server performs all of the replications in the replication system, but there may be more complex environments that consist of combinations of the multiple types of replication servers that you see listed here. So as with the primary servers, replicate servers must be monitored for status, and the replication environment must be monitored for the additions of new replication servers and the related routes. So in addition, increases of the flow of data between replicate servers can cause issues, and so that too must be monitored. So looking at connection and routes, these are critical components of the replication server, and they need to be monitored to determine if the replication data is replicating smoothly or if there's any issues that may impact the data flow. So for physical connections, we need to make sure the database connections are up and running. For logical connections, mainly used in warm by standby environments, it's important to additionally verify both the current and standby connections as well. So changes in the size of the outbound queues can be an indicator of issues with the direct and indirect routes. So monitoring the state and the values of the locator sent and locator deleted columns returned by the admin Who RSA command can be used to alert us that there's still data to be processed by the replication server for a particular RSI, an indication of a possible problem with our replication. So it's equally important that we monitor the status and the movement and the size of the data flowing through the inbound and outbound queues. So if the connections are active, but it appears that data is not getting replicated, then looking at things like duplicates, first and last segment blocks, size next read, commands per minute, things like that can be useful for pinpointing replication issues. So when we talk about replication agents, and Chris gave us a good description of those, but replication agents, when we're talking about as ASE, are internal threads in ASE that scan the transaction log for the transactions that we want to replicate into the replicate database. So here we need to make sure that the replication agent is collecting the marked data and forwarding it to the replication server and subsequently resetting the secondary truncation points. So monitoring the sleep status column will give us a current status of the replication server. Statuses can be not running, not active, initial, end of log. So it's important to monitor the statuses of the replication servers. So monitoring the replication threads is critical as well. So this slide lists a few useful things to verify concerning the replication threads, and most of this information can be obtained through the admin who, SQM, SQT, DST, and DSI commands. So there's a lot of useful diagnostic information that we can get by perusing the many error logs in the replication environment. So here is a list of the available error logs and some tips on what to look for in each log. So it's important that we're familiar with the error logs and we have some type of mechanism that peruses those files and lets us know any of the errors, warnings, and things like that that are in these logs. There's some specific error codes in the replication error log that are particularly important. Here's a list of them. I'm sure many of you are aware of these, but the H, the F, and N codes are particularly important. Replication thread died, F is replication server died, internal errors. These are things that are very critical to our environment. Also, we can get information on the stable device partition failed or possibly not available for some reason. And we can also see error messages on loss detection. So I'm going to move into the surveillance DB architecture and show you how we actually monitor the replication server environment and the different pieces of the solution that become important in implementation. So it is a client-server configuration. In the center, we have what we call our SAM, our Session Agent Manager. And the Session Agent Manager controls all the communication between the various clients and the database itself. So within the Session Agent Manager, we have a number of collection sub-agents. And depending on what you're monitoring, you'll have various combinations of the collection agents that you see here. And we also are heterogeneous in this area, so we're monitoring Sybase, Microsoft, Oracle, IBM, and other databases. The collection sub-agents connect to the different database and gather the information, the metrics, things that we need to be aware of. Now, this information is passed to an analyzer sub-agent. The analyzer sub-agent is a rule-based procedure, and it actually analyzes the data coming from the collection agent and applies a series of configured rules that contain thresholds and timings and things of that nature. So if the collected data that the analyzer is looking at exceeds any of the thresholds that's specified in the rules, it passes an event to the alerter. And once the alerter receives the event, it can execute a number of different alert actions. So it can do emails, SMS, run external commands or scripts, write messages to the console, issue HTTP requests, things of that nature. So using the solution, you're not tied to continually looking at the client and connecting to the SAM to get this information. It's unattended, it's anonymous, it's located on the agent. So if any of the thresholds or the values that you're concerned about are breached, then it's automatically going to alert you. The third piece of the SAM is the repository subagent. And the purpose of the repository subagents is to take the collected data and store it in one of two repositories. Now, in surveillance, there's two repositories, what we call the local repository and what we call the centralized repository database. The local repository is a set of files on the server itself. The data is collected, and based on the data store rules configured into the product, it moves data into the local repository for certain features in the product, like data flashback, that allows you to go back in time and look at historical data using the same real-time screens that you normally are looking at. Okay. So the data that's collected by the collection subagents is real-time data, so it's what's actually happening at the moment in your replication server environment. But you also have the ability to go back and research hours, days, weeks before research and figure out why problems have actually occurred. Optionally, the data can be written to a historical repository. This is a long-term repository. It is a relational database that can be in any of the major database flavors. Since it is a relational database, you can access it with the report viewer product that's inside Surveillance DB, or you can use any ODBC compliant report writer to get to that data. So the data stored here is long-term data for things like trending, long-term performance analysis, capacity optimization, and things of that nature. Product also contains functionality that controls the size of the repository database. The two different repositories, you have the ability to specify specifically what data you want to go into each of these. It doesn't have to be the same. You might want more detailed data in the local repository for problem analysis, and you might want more generalized, summarized data in the historical repository for reporting. So here's a list of, I talked about the analyzer using rules to look at the collected data. On the left here, we have some ASE analyzer rules. These are for ASE, but they're relevant to Replication Server. I've highlighted a few of the more important ones here. So if we're replicating into an ASE database, then we can see certain statistics about our replication environment in ASE. Things like, is our rep agents getting behind, and how far behind are they? Status of the rep agents. Have any of the replication agents lost connections or gone down? And another important one is replication latency. We're dealing with real-time data. RepServer is replicating data in real time, so latency is a concern. So any of the rules that you see here, we can alert on those and send out the different, or execute the different alert actions that I showed earlier. For Replication Server itself, there's a different set of rules for Replication Server. Some of the ones that seem more critical to customers are failed transaction activity. Any of the transactions failed in replication. I talked about the different errors. We're also scanning the various log files. We can alert on certain messages that are written to the log files. If there's an issue in replication and we can't move the data out of the queues, then our partitions begin to fill up. So we've got several different rules based on that. It's filling up fast, it's full, things like that. Also monitoring all the different threads. So any of the threads go down, then we're going to alert on that as well. So any of these rules can be modified to fit your environment, or you can copy these rules and recreate additional rules looking for specific things that you deal with in your environment. I'm going to talk briefly about the event handlers. This is some of the configuration screens that we set up. Here's some of the actions that occur. So it's very simple to set up the alert rules. here's some of the selections that we can use in the rules itself, different types of email. Forwarding is an important one. Forwarding allows us to monitor multiple servers and forward those alerts to a single server. Okay, so it gives us a way to manage a large number of servers from a single SAM. Okay, I wanted to go ahead and go through a couple of the screens here in the product itself. What we're looking at is a general health, replication server health screen. So you can see things like configuration, information, suspect threads. It's also giving us information on the partition space. These have drill downs. I can drill down and see where these are located, what's it allocated, how big is it, things like that. There's a number of tabs with additional information. Here we're looking at the general tab. So it's monitoring things like rep agent, total megabytes of the LTL that's transferred into the RepServer from all the replication agents. The inbound SQM is displaying the commands per minute written to inbound stable queues by the stable queue manager. The SQT graph here is displaying a summary of the work processed by the stable queue transaction threads on the inbound queues. Here is the distributor. It's displaying a summary of the work processed by the distributor threads. The DSI is a summary of the workload performed by the data server interfaces, processing transactions into the replicated databases. And if you're replicating into remote servers, then the RSI is going to show us the megabytes per minute sent to remote replication servers through the RSI. Okay, I'm moving to another tab on the product, and this is dealing with the replication agent tab. And these graphs actually show the data flow into the RepServer by the replication agent. So here we can see the identifiers, we can see the average megabytes received per minute, how many commands per minute are executing, and how many packets are actually being moved across the network. So this is the SQM, and here we can see the inbound and outbound stable queues managed by this particular replication server. We can see the size of the next reads. We can see the different segments, first, second, next, segment blocks, next reads. Again, how many commands per minute, percentage of full blocks, for percentage of cache read. Any of these identifiers are also being monitored. If something happens to them, then they will actually turn red and immediately notify us that there's an issue. There's two SQT tabs. So the SQT status tab it provides a point in view time of statistics that are related to the current content of the SQT queues. So surveillance is monitoring the time it observes the same first transaction being processed by the SQT threads and the change in the number of commands that are processed so far for that transaction. And this is useful information and can be a key indicator of long transactions or uncommitted transactions. So as a note, here in this particular screen at the time I took this snapshot, my CentOS 64K Plus it was in a locking situation, so it turned red and notified me of that. And it also listed it up here in the suspect threads. So that's some of the main screens in surveillance. There's many more. We don't have time to get in all of those today. But I just wanted to give you a quick feel of some of the information that we're actually gathering and displaying for you. So it collects the information for us, it automates that process, and displays it in an easy way to see in digestible format. Okay, so in summary, I just wanted to mention that we've been a strategic partner with SAP since 2005. We're also a reseller of SAP ASE, RepServer, and IQ. We've been the recommended solution for monitoring SAP database environments for a while now. And the 3 points that I'd really like you to leave with is that Surveillance DB automates the collection process for you, which is going to save you a lot of time. The dashboards facilitate problem isolation for you, and then we also provide automated unattended event management. So that's, I see we're a few minutes over. That's a quick highlight of the Bradmark solution for SAP Replication Server. And I guess at this time, I'd like to go ahead and turn it back over to Mike.
Thanks, Bill.
Hey, Mike, this is Chris.
We will move. Hey, Chris.
If I could interject just one thing. Monitoring Replication Server can sometimes be an interesting art, and I do mean that literally. A lot of customers use some very basic admin commands to do that, and we have the whole concept of managing Replication Server and looking at RepServer through the monitors and counters, and that can be quite a formidable task to do that, even for people like myself and in my group. So I really am a big fan of this product. I think that Bradmark has done an excellent job of being able to take and interpret that data and really give you, the customer, an excellent way to really drill down deep into your environment and look and see what's going on and do that historically. I've met many of their developers, and they're top notch, and this really is a good product. And I'm a big fan of it. So I just want to say, Bradmark, I really do like your tool, and I think it's awesome.
Thank you, Chris.
Well, that was a great recommendation. Good job, Chris. And as somebody who's also been familiar with Bradmark, and I can also second what Chris has said, we are running a little late, so we're going to zoom very quickly to the Q&A with the questions that did come up during the presentation. First question is, there a PDF available? There will be a PDF slides posted alongside the replay that will be up on the ISOC Tech site within the next couple of days. First question for Chris. Can Replication Server be used for HADR solution at the data server level rather than setting up warm standby for every database?
It's more of a database level type of environment. So you publish the database, and then you just do like an MSA or multi-site type of availability. So it's more database level versus taking the whole data server and failing it over.
Okay, thank you. And then there are a couple of questions here related to something I'm not 100% sure what's being referred to, but I believe the question is related to Power Designer. The primary question, and it basically asks, can it reverse engineer an existing topology, creating the DDL and topology flow diagram in Power Designer for documentation or migration purposes?
The answer to that is yes.
Okay.
Yeah, yes, it can.
Good question. All right, so next question. I was a big proponent of replication out of HANA, but if you have terabytes of data and IQ index, what good would the data do outside of HANA?
Ask that again, Mike.
It says the questioner says that they were a big proponent of replication out of HANA, but if you've got terabytes of data and IQ is indexed, what good would it do outside of HANA? And I think the question's asking is, why would one want to replicate outside of HANA?
Well, I think that, there's a couple answers to that. One is that SAP is positioning HANA in a couple of different ways. One is as an underlying database right now for the business suite and for the entire SAP application stack. So if you're going to move data out of an application like that, no matter what the backend data store is, there's business value in replicating that out to either a warm standby environment or even possibly to other target databases that may want to subscribe to data that's being generated by that application. So it really, to me, is the same central question you would ask about why you want to replicate out of any other database or any other application. I mean, the same concept still applies. The difference here is that we'll be able to replicate that directly out of HANA as a new source.
Okay, great, thank you. And a question which you may not be able to answer, and that is, somebody asked, how soon will HANA to HANA replication be supported?
I've asked that question myself, and product management would shoot me on site if I even committed to a date, but I know that it is planned, and I'll just leave it at that.
Okay. All right. RS subcompare is very successful between ASE to ASE, but the questioner is asking what to use when comparing between, say, ASE and Oracle or Oracle and Oracle.
Data assurance by far.
So data assurance, no plans to enhance RS subcompare for those other databases?
None that I know of. I would wholeheartedly recommend data assurance. You know, and I'm not a big fan of trying to get people to buy something just for buying its sake, but you know, that particular option of Replication Server is pretty good stuff. And you know, I've done benchmarks on it, done tech ed and tech wave sessions on it. It is very much worth the money. And for doing heterogeneous environments, no matter what the source or target, it's the best way to go.
Okay, great. Somebody asked, have you done any performance benchmarks between Rep 15.5 and 15.7.1?
No, I have not.
Are you aware of any that is maybe on the SCN side anywhere?
I'm not aware of any. That doesn't mean that there aren't any there, but I have not personally done or seen any. You know, but there's been quite a number of enhancements between those versions. So I think it really, you got to look at, you know, are you taking advantage of the additional features and capabilities that are in each product? For example, you know, SQL statement replication, bulk library interface, some of the ASCII packing stuff, some of the normalization things that are there, you know, plus the internal contingent points that have been eliminated between the versions. So I think that on the whole, the performance is much greater, but you know, if you're not exploiting those features, then you won't realize it either. So it's kind of like a horse, you know, chicken and an egg problem there.
Okay. And the last question for you is somebody asked how they can get more information on change data capture because they're interested in that feature for a data warehouse project.
I would talk to your SAP AE. If not, email me, brown.chris@sap.com. I'll figure out who you need to talk to, whoever asked that question.
Okay, great. Okay. Oh, and sorry, there is another question for you, and that's whether zero data loss will be a premium option.
I believe so, but you know, I have not seen the final on that, but my suspicion is yes.
Okay. All right. Question for Bill. Bill, it has to do with the repository for the Bradmark tool. Basically, does the local repository or the centralized historical repository need to be Oracle?
Absolutely not. It can be. You're asking if it needs to be Oracle?
That's the question.
Yeah. No, it does not need to be Oracle. It can be in Sybase, DB2, SQL Server, any of the major database.
Okay. So there's no forced repository in any particular database server. Excellent.
No, not at all.
And then just a question, not about the Surveyor's tool, but somebody remarked that it was a great presentation, Bill, and they liked the highlighter that you were using, and what software are you using to do that?
Oh, the highlighter, that's actually a function that's in PowerPoint itself, and thanks for the nice comment on the presentation. You can right-click on a slide, it'll bring up a menu, and I was just using highlighter there.
Okay, great. And are there monitoring options for millisecond latency?
I'm sorry?
Are there any monitoring options for millisecond latency?
I'm not sure I understand that question completely. We do have a number of different ways that we monitor latency there. It is reported in milliseconds. Is that what the question's asking?
Yes, that is the question.
Then the answer is yes.
Okay. And I'm going to go back to the repository question again because the questioner is quite adamant about this and is saying that the local repository has to be in Oracle.
No. It depends on which database you're actually monitoring. If you're monitoring an Oracle database, then the local data store is just in files on the server, and it's not database related. The long-term repository, even if you're monitoring Oracle or DB2, could be in Sybase or Oracle or either of those. So there's no.
Okay, so local one is files only.
Yes, the local repository is files only on the server itself.
Okay, great. All right, well, Chris and Bill, thank you very much for the presentation today. Wonderful. That's all the questions that we had. A lot of questions that came in. Appreciate people spending their time with us today. We will have the recording online as soon as we can, along with a copy of the slide presentation. And that is the last TechCast that we've got scheduled for this year. Don't forget to check out the information about the ISAC Tech Conference, which is at www.isugg.com/TechWave2014. That's TECHWAVE 2014. And again, our call for papers is open until Monday, so if you do want to submit, now is the time to do so. Everybody, thanks for attending. Bill, Chris, again, thank you very much for your hard work and presenting today. We appreciate that. And everybody have a happy holidays. We'll see you in the new year.